There is a principle embedded in how sleep actually works that directly contradicts what most people do when they cannot sleep. The harder you try to fall asleep, the less likely you are to sleep. This is not motivational framing. It is a description of a neurological mechanism that operates independently of whether you believe it, whether you find it frustrating, or whether you have heard it before. And understanding it at the level of mechanism rather than as a vague piece of advice changes every decision you make in the hour before you close your eyes. Sleep belongs to a specific category of experiences, alongside genuine laughter, creative insight, and certain states of flow that cannot be directly pursued. They can only be created conditions for. The moment you place sleep as a goal to be achieved through sustained effort, you activate the very cognitive systems whose deactivation is required for sleep to begin. You have assigned yourself a task that is structurally impossible. Use the executive functions of your brain to shut down the executive functions of your brain. Monitor your own disengagement. Pursue your own surrender. It cannot be done, not because you are failing, because the design of the attempt guarantees failure. Every conventional piece of advice that tells you to try harder, count backwards, breathe slowly while tracking whether it is working, imagine a peaceful scene with sufficient detail to keep the mind occupied, stay in bed longer, and eventually force the body into submission, assumes that sleep is an achievement, something that sufficient effort applied in the right direction will eventually produce. But the nervous system does not respond to force the way muscles respond to training. It responds to signals, to the presence or absence of specific physiological, thermal, and environmental cues that tell it whether this is a time for action or a time for repair, and you can provide those cues deliberately, bypassing the cognitive level entirely. The Japanese understood this not as neuroscience, the formal study of which did not exist when these practices were established, but as practical wisdom compressed into habits and transmitted through generations because they worked consistently across millions of people in conditions of varying stress, varying environments, and varying personalities. What sleep research over the past 3 decades has progressively confirmed is that the mechanisms underlying these habits align with near precise accuracy with what the biology of sleep onset actually requires. What follows is not another technique to apply with effort. It is a reframing of the problem, way, and a sequence of actions that emerge naturally from that reframing rather than conflicting with it. Subscribe to this channel now. The content here is built on mechanisms, and it will treat you as someone who can understand the real explanation rather than just the surface instruction. The reframing begins with understanding what the racing mind actually is, not as a character trait, not as a symptom of an anxious personality, but as a neurological function operating at precisely the wrong time in precisely the wrong context. The default mode network is a set of brain regions, including the medial prefrontal cortex, the posterior cingulate cortex, and the angular gyrus, that activates when the brain is not engaged in a directed external task. During the working hours of a day, any cognitively demanding activity suppresses this network. The brain's resources are directed outward, but the moment you remove all external demands, when you lie down, switch off the light, and eliminate all stimulation, the default mode network fires at full intensity. Its function is to process unresolved memories from the day, anticipated future scenarios that have not been worked through, social situations that are incomplete, thoughts that accumulated throughout the day without a natural moment for integration. What you experience as the mind refusing to stop is this network finally having the silence it has been waiting all day to work in. This is not pathological anxiety. It is normal neural housekeeping occurring at a structurally inconvenient time. And the reason it occurs at night specifically is that modern life provides almost no natural gaps during daylight hours in which this housekeeping could have taken place. The brain arrives at the pillow carrying the full cognitive load of the day, and it begins its processing the moment the silence of the bedroom allows it to. The second element is the autonomic nervous system, and the specific mode it must be in for sleep to begin. Deep, restorative, slow-wave sleep, the kind that repairs tissue, consolidates memory, releases growth hormone, and restores the hormonal calibration that governs appetite and mood the following day. Requires the parasympathetic nervous system to be dominant. The parasympathetic system governs rest, repair, digestion, and recovery. It operates when the body perceives no active threat. Its counterpart, the sympathetic system, governs alertness, readiness for action, and response to perceived danger. Both systems exist in the body at all times, but they cannot simultaneously operate at full capacity, and in a body under chronic modern stress, elevated cortisol sustained by screen light late in the evening, morning, unresolved emotional content from the day, the background hum of tasks not yet completed. The sympathetic system remains active well past the point at which the parasympathetic should have taken over. You cannot decide to activate your parasympathetic nervous system the same way you decide to lift your arm. It does not respond to instruction, it responds to signals. And the philosophical insight that changes everything is this: the path to sleep is not through greater effort, it is through the systematic removal of the signals that are keeping the sympathetic system in charge. The first principle that emerges from this understanding is one that the Japanese concept of ma has encoded for centuries. Ma is written with the kanji jan and translates most directly as interval, space, or pause. The quality of emptiness between things that gives those things their meaning, their shape, their possibility. In Japanese music, ma is the silence between notes that defines the melody. In Japanese architecture, ma is the unoccupied space that makes the room inhabitable. In Japanese martial arts, ma is the precise distance that makes effortless movement possible. Too close and movement is blocked. At ma, movement flows. Applied to the transition into sleep, ma is the deliberate dissolution of the pursuit of sleep itself. You are not trying to sleep, you are not monitoring your proximity to sleep. You are creating the interval in which sleep can occur without being obstructed by the act of reaching for it. Neurologically, this has a specific correlate. The prefrontal cortex, the brain's executive center, governing goal pursuit, progress monitoring, and executive decision making, must substantially deactivate for deep sleep to begin. When you are actively trying to sleep, the prefrontal cortex remains engaged. It has a task. It is monitoring progress toward that task, and it is evaluating whether what you are doing is working. That engagement prevents the deactivation that the task itself requires. Ma breaks this loop by removing the task. There is nothing to monitor. The interval is not a waiting period in which you are waiting for sleep. It is the condition itself. And in the absence of the monitoring function, the brain's electrical activity begins the natural descent from beta waves, the pattern of alert wakefulness toward alpha waves, the threshold state between waking and sleep. The transition begins not because you forced it, because you stopped preventing it. The second principle involves a direct physiological intervention in the autonomic nervous system that bypasses the cognitive level entirely. The physiological sigh is a specific breathing pattern that produces a measurably faster shift from sympathetic to parasympathetic dominance than any other respiratory pattern that has been studied in a laboratory context. The sequence is a double inhalation through the nose. A first inhalation to the normal lung capacity, followed immediately by a second brief inhalation that pushes the lungs beyond their usual volume, fully inflating the alveoli, including those small air sacs that remain partially collapsed during normal breathing. This is followed by a long, slow exhalation through the mouth that is considerably longer than both inhalations combined. The mechanism is not metaphorical. The double inhalation fully expands all alveolar surfaces. The extended exhalation produces a carbon dioxide transfer that activates the vagus nerve. The vagus nerve communicates that signal to the brainstem, which interprets the elevated CO2 as evidence that the body is in a state of safe rest, not emergency. Heart rate decreases, peripheral vasculature dilates, blood pressure drops slightly, and the body sends itself an unambiguous chemical signal that no active threat requires response. This signal does not pass through the prefrontal cortex. It does not require belief, a calm mental state, or favorable circumstances. It requires only the correct mechanical sequence. 2 to 3 physiological sighs performed consecutively produce a state shift that is detectable in heart rate variability measurements within minutes. It is the nervous system's own self-regulation mechanism activated intentionally. The third principle addresses the body itself, specifically the loop of feedback between muscle state and brainstem arousal. Muscle tension, even at low levels, sends continuous ascending signals to the brainstem indicating that the body is in a state of readiness for action. This is appropriate signaling when action is genuinely required. At night, in a body lying in a safe environment with no threat present, it is noise, a low-level but persistent signal that the body remains in guard mode. Progressive muscle relaxation, the systematic, intentional release of tension from each major muscle group in sequence, works by reversing this signal. The protocol, developed during the Second World War by US military trainers for combat pilots who needed to be able to fall asleep in any conditions, proceeds from the face downward. The forehead is released, then the muscles around the eyes, the cheeks, the jaw, the tongue, the lips. The shoulders are dropped without support. The arms are released from shoulder to fingertips. The chest is released on a long exhalation. The abdomen, the thighs, the calves, the feet. Each region, released intentionally, sends a message of safety to the brainstem from that part of the body. When every major muscle group has sent that message simultaneously, the brainstem receives a comprehensive picture. Nothing in this body is preparing to act. Nothing in this body is detecting danger. The neural conditions for sleep onset are present. Among the pilots who practiced this protocol consistently for 6 weeks, 96% reported being able to fall asleep within 2 minutes regardless of environmental conditions. Not because 2 minutes is magical, because when the conditions are correct, that is how long the transition takes. The fourth principle is thermal and is directly connected to the Japanese practice of the ofuro, the pre-sleep hot bath, though the mechanism is more counterintuitive than the practice itself suggests. Core body temperature must fall for deep sleep to begin. This is among the most consistently replicated findings in sleep science. Temperature descent is not a consequence of sleep. It is one of the primary conditions the pineal gland uses to intensify melatonin production, which initiates the sleep architecture cascade, and the most efficient way to produce this descent is not to cool the environment. It is to heat the body first. Immersion in water at 40 to 42 degrees Celsius for 15 to 20 minutes before bed raises core body temperature. Upon leaving the bath, the body begins actively dissipating that heat, and core temperature falls more rapidly and more substantially than it would have fallen from an unheated baseline. That accelerated descent is among the most reliably documented triggers for the initiation of slow-wave sleep. A simplified version of the same mechanism, warming the feet with thick socks for several minutes before removing them, produces a smaller version of the same effect through peripheral vasodilation, which redistributes heat away from the body's core and creates the temperature gradient that the brain reads as the appropriate signal for sleep onset. The fifth principle addresses the default mode network directly and is the one that consistently produces the most surprise in clinical sleep context because its mechanism runs counter to intuitive expectation. Researchers at Baylor University compared individuals who spent 5 minutes before bed writing about what they had accomplished during the day against individuals who spent 5 minutes writing a detailed to-do list for the following day. The to-do list group fell asleep significantly faster, not because making a to-do list is relaxing, but because the thoughts that intrude most persistently at night are predominantly open loops, tasks that are incomplete, decisions that have not been made, concerns that have not been resolved. The brain maintains these in active working memory because, evolutionarily, forgetting an open item could carry consequences. When you write the item down, not to solve it, but purely to externalize it, the working memory system receives confirmation that the item is stored and retrievable. It can release it from active maintenance. The default mode network loses the fuel that was keeping it running at high intensity. The time to sleep onset decreases in a statistically significant way. These 5 principles, Ma as the dissolution of the pursuit itself, the physiological sigh as the autonomic switch, progressive muscle release as the body's safety broadcast, thermal descent as the pineal trigger, and cognitive offloading as the default mode network's fuel removal, which are not 5 separate techniques to be applied in isolation. They are 5 interventions in the same biological system, each addressing a different layer of the same fundamental obstacle, a nervous system that is still receiving signals to remain active in a context that requires its deactivation. The Japanese approach to sleep is not a discipline. It is a philosophy of removal. The question is not what you need to add to your pre-sleep routine to force sleep to happen. The question is what is currently preventing sleep from happening on its own, and what is the minimum intervention required to remove each of those obstacles in the sequence that matters. Ma removes the cognitive obstacle of goal monitoring. The physiological sigh removes the neurochemical obstacle of sympathetic dominance. Muscle relaxation removes the proprioceptive obstacle of tension-based arousal signals. Thermal management removes the biological obstacle of insufficient temperature descent. Cognitive offloading removes the attentional obstacle of open loops held in working memory. When each obstacle is removed in sequence, what remains is a nervous system that has no remaining reason to stay awake. And in a nervous system with no remaining reason to stay awake, sleep does not need to be forced or invited or pursued. It arrives as the default state, which biologically it has always been. The 2-minute claim is not hyperbole. It is the approximate time required for the parasympathetic cascade initiated by the physiological sigh, the complete muscle release, and the absence of prefrontal monitoring to reach the threshold of sleep onset in a body whose temperature has been allowed to descend and whose working memory has been cleared. The conditions determine the outcome. The outcome does not require your effort. It requires the absence of your interference. This is the philosophical reframe that the Japanese concept of Ma makes possible. The path to sleep is not the path of doing. It is the path of undoing, and every action in this sequence is an undoing of tension, of vigilance, of goal orientation, of the accumulated signals that have been telling your nervous system all evening that this is still a time for wakefulness. If someone you know describes their mind at night as something they cannot switch off, as a browser with too many tabs, as a conversation that will not pause, as a machinery that runs regardless of how tired they are, share this video with them, not as advice, as mechanism. The mechanism is what they have not been given, and without it, every technique they try will be applied in the wrong direction. And in the next video, we are going to examine why the number of hours you sleep may be one of the least informative variables in predicting how restored you feel upon waking, and what the research identifies as the factors that actually determine it.